The Nuclear Regulatory Commission stated that once a crack starts, it will continue to grow through the wall, and it will take about 16 years to grow all the way through. I was actually at a meeting when they said this, and I was shocked that they have no plans to be able to find the cracks or repair the cracks. This was unbelievable information, but it's true. And unfortunately, we have about 3,200 of these canisters currently installed around the country.
So Donna Gilmore, thank you again for joining me. And today we're going to narrow our discussion. We're going to discuss the casks versus the canisters. The canisters being the thin-walled system that's in use in the United States versus the casks, which are thicker-walled systems in use in the rest of the world. Okay. Let me start by sharing an image of the thin-walled canisters. This particular one is manufactured by, you've told me, Holtec International, and this is what's used in the United States.
Yes, notice the walls are very thin. It's a half-inch thick wall, and that is our protection from nuclear waste, is that half-inch thick wall in the United States.
I want to go on to this image and ask you to explain to me, what are we seeing here?
Well, the Nuclear Regulatory Commission says that these canisters, they're stainless steel, are vulnerable to cracking. And this is a blow-up, a microscopic blow-up of what the cracks look like. This isn't an actual canister, but this is the same material. And once a crack starts in stainless steel, it continues to grow through the wall undetected. And the NRC told me, and they have put this in writing, that it will take about 16 years for the crack to grow through the wall.
Now, I always like to explain the acronyms. NRC is the
Nuclear Regulatory Commission stated that once a crack starts, it will continue to grow through the wall, and it will take about 16 years to grow all the way through. I was actually at a meeting when they said this, and I was shocked that they have no plans to be able to find the cracks or repair the cracks. This was unbelievable information, but it's true. And unfortunately, we have about 3,200 of these canisters currently installed around the country.
Again, to be fair, this image is not an image taken of one of these canisters cracking, but it's an image taken of similar stainless steel that's been subjected to conditions that are similar to what the canisters are subjected to. Is that correct?
Correct.
Want to be fair, that's not actually one of these canisters in use, but as we'll learn in a few minutes in our discussion, this could be happening invisible to us from what you've told me already, with no way of detecting.
And some canisters are already 27 years old. The ones at Calvert Cliffs in Maryland, they're already 27 years old. And the only thing the NRC has done is eliminate the requirement for them to measure radiation levels at these outlet air vents where these canisters are stored inside.
So rather than enforcing greater inspection and regulation, they've eliminated the requirement to measure?
To measure radiation out of the, we're going to go into the air vents later, but to measure the radiations where the highest radiation levels will be with through-wall cracks, yes.
That's their answer to nuclear safety, is stop looking.
Exactly.
Okay.
Hide the leaks from the public.
This is the Nuclear Regulatory Commission that you and I know is called a captive regulatory agency, because they are pretty much controlled by, owned by the industry that they're supposed to be regulating?
Well, you have 5 NRC commissioners. They are appointed by the president, but they have to be confirmed by the Senate. And when Obama was president, he could only get one safety conscious commissioner approved through the Senate. That's part of our problem.
Because the Senate was controlled by the Republicans, by the Republican Party, or perhaps by industry lobbying of the Democratic Party as well, to be fair.
Well, it would be interesting to see how things change, but it's kind of been historical that the Democratic Party puts more safety conscious commissioners.
We will de-emphasize the political aspect at this point. The world is, the country, the United States, is already divided enough on the political scale. Okay, so what are we looking at here?
What we're looking at here is a typical canister used in the United States. This is an above ground canister. The blue is the thin wall canister, 1/2-inch thick canister. It's stored inside a concrete cask, but with a steel lid on it. The thin canister doesn't stop gamma rays and neutrons, so it has to always be surrounded in something like thick concrete, or you would die if you stood next to it. And the problem is there's air vents in that thick cask. There you'll see inlet air vents at the bottom and at the top. The air goes in the bottom, comes out the top, and that's critical to cool this canister in the fuel, because the canister is hotter than a furnace, and it has to be continuously cooled. So,
Okay, so these canisters now, they are sealed, and from what you've already told me, they are welded shut. They're not bolted. They can't be opened.
They can't be opened. They're welded shut. These are pressure vessels, yet they have no pressure monitoring and no pressure relief valve. The Nuclear Regulatory Commission gives exemptions from typical safety standards that people have to meet with pressure vessels.
I want to call everyone's attention again to the fact that there is airflow required to come in through the bottom, cool air, and warm air out through the top, or hot air, because these waste storage fuel assemblies are still hot when they're put in there. If these thin-walled canisters develop cracks and there is a leak, then that leak will come out naturally vented through air convection. Let's take a look at the assemblies themselves. So these are the nuclear fuel assemblies. Can you tell us a little bit more about
this is one fuel assembly. A fuel assembly is made up of those rods you see to the right. The nuclear fuel pellets, these are uranium pellets, are inside. They're stacked one after another. They're about the size of a pencil eraser. And those rods with the fuel pellets in there make up that one assembly there. So there's a whole bunch of fuel rods in one assembly.
So you've got perhaps several hundred of the rods grouped together, and within each rod there's dozens or perhaps 100 or more of these tiny little pellets.
Yeah.
Again, moving back to, that is what the green honeycomb, you called it before, is. It's
right. Yes. And there's usually 24 to 37 fuel assemblies in one canister.
Okay, I'm going to skip around. I want to go back to the beginning, that initial photo that we showed. So there you're seeing the holes in which those assemblies are loaded.
Yeah, they call that a basket, fuel assembly basket, and each fuel assembly bundle goes in, one goes in each slot.
And then a cover is put on and it's welded shut.
Right, they have a stainless steel cover, thick cover they put on, and it's welded shut. And the fuel is not adequately inspected before it goes in, and it actually degrades during dry storage.
Tell me more about that. What do you mean the fuel is not adequately inspected?
Well, when you burn this fuel in the reactor, you end up creating highly radioactive fuel rods, with the fuel rods themselves, they call cladding, and the fuel pellets getting damaged and building up hydrogen in them. And the big concern is that these may fall apart during storage or in transport. The NRC is actually concerned. They don't know if these rods with normal train vibrations would withstand a trip on a train somewhere else.
They've already been stressed out by the radiation that's coming from within, from those little pellets.
Right, right. And the canister is filled with helium so that nothing explodes, because you don't want oxygen in there. That's an explosive thing to have in this system. And so they fill it with helium because it's an inert gas, but they have no way to know if the helium is leaking out. They have no monitoring system to know what's going on. And they only check the radiation levels from the air vents once every 3 months. They walk around with a monitor on a stick and check it. But now they're only checking the inlet air vents where radiation levels would be lower. There's some radiation comes out of those vents anyway. They do monitor for temperature. There is temperature monitoring, but none of that monitoring is going to give you a warning. There's nothing that alerts you soon enough to do anything about the problems. We will only know after it's too late, after major radiation leaking is happening. We won't know before. And then we'll only know if the NRC tells us or if the canister explodes. So they're vulnerable to hydrogen gas explosions, air, water gets in, you have a potential issue of a uncontrolled nuclear fusion reaction if water gets inside.
We have two potential classes of problems there. One of the problems is that there may be an invisible leak of radiation of potentially major proportions. Now, you've already told me that there are minor, shall we say, small amounts of radiation that come out of these and are vented into the air in the natural course of doing business, shall we say?
Yeah, the thin canisters don't stop gamma radiation or neutrons right off the get-go. So we have some canisters at San Onofre. Somebody measured the inlet air vents on those, and some of them were measuring 200 counts per minute. Others 800 counts per minute. I haven't been able to get anybody to say why the counts are higher in some rather than others, or they're just kind of hiding information from us right now. Those are 17, some of those are 17-year-old canisters.
When you say counts, we're talking about Geiger counter clicks.
Geiger counter clicks, yeah.
And if you're having, what was the number you used? How many per minute?
Some of them are per minute, 2,000 counts per minute.
2,000 counts per minute is like click, 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 click. Yeah, fast clicking. So we've got a lot of, some of them are leaking a lot of radiation as it is. And going back to your presentation, what we're looking at here now is above ground, thin-walled canisters.
Okay, the thin-walled canisters are inside these thick wall casts. These thick wall casts, they're made of concrete and they're lined on the outside and inside with carbon steel. And you'll see in the bottom right, you'll see one of the air vents. There's like 4 air vents at the bottom. And then at the top, you see one of the air vents. So that's the air cooling system. This picture happens to be from Diablo Canyon. And they store them very close together. So those are sitting out in the ocean air. The NRC admits the ocean air is one of the things that can corrode and start the cracking process in these canisters. But we have no idea. We have no idea because they have no inspection technology that can go through those air vents and be able to see cracks. It just doesn't exist. These canisters were designed to not be inspected.
Camera down into your blood, essentially, and a little remote, a pill that you can swallow with a camera. We have the technology but they left that out of this.
Well, you can put you can get a camera part way down through the hole, but these are microscopic cracks that you cannot see with a camera, and they can only get certain small areas around. American Society of Mechanical Engineers that sets standards in this country. The only way you can find cracks, it's approved, is by putting a fluid dye on the surface of the cracks and see where it runs in the cracks. And you can't, once you put fuel in there, once you put this hot radioactive fuel in there, that option, you can't use that option. So they knowingly stored the most lethal material on Earth in uninspectable canisters, assuming after 20 years, these utility companies that bought these could turn it over to the federal government, so the federal government would have to figure out what to do with this mess. That's the nuclear industry plan in the United States.
We call that an externality. And so the companies that run these power plants are more than willing to leave as an externality, taking care of the waste, with the expectation that the government, when I say the government, we mean the taxpayers, are going to pick up the tab.
Yes, and there's no funding for dry storage. So they wanted the least expensive. I mean, these were roughly $4 million a piece, each one of these. And that was the less expensive option. And they just chose the least expensive. There's no fund anywhere to pay for these dry storage containers.
Could you hazard a guess as to what the thicker walled casks cost by comparison? And we're going to discuss those in a minute.
The forged steel cost, Prairie Island paid $6 million a piece for those, but the lifespan is going to be longer for the thick ones. They don't have the cracking problem. So they really are less expensive if you look at past 20, 30 years, and they're maintainable. And they're the ductile cast iron. We don't have a cost on those. I was told that they would be competitive to the thin ones now because ductile cast iron is less expensive, but I don't have any numbers. We can't get any U.S. utilities to even allow the thick ductile cast iron bids. They won't even allow them to bid the jobs.
Okay, let's go back to your slides again. And again, those are the above ground concrete casts.
Yeah, there's three companies that make above ground systems: Holtec, NAC, and Transnuclear. They make the thin wall canisters. That's pretty much it.
Okay, but they're equivalent.
Yeah, they're very similar. I mean, they all use the same thin stainless steel product, have the air vents, one design. It happens to be stored sideways. These are upright. So, and then I think we're going to show the one other way they're stored.
Let's move on down the line here.
Okay.
Now, what we're looking at here is the decommissioned San Onofre nuclear power plant. And what I'd like to call people's attention to is how close it is to the Pacific Ocean. It's perhaps 40 yards away from the ocean, from salt air.
Yeah, over 100 feet, yeah.
Now, you've also told me that what we're looking at here is the area where the canisters will have been installed by now, but that does not show them because they weren't installed when this photo was taken.
Yeah, Edison, Southern California Edison likes to share this picture because it doesn't show the huge air vents because this makes it look like everything is all sealed up below ground. So it's a very misleading picture.
It's a bit of propaganda.
Yeah, yes. Yeah, and so if you look at the next picture, now you can see the air vents on there. The lower rectangular part is the inlet air vent, and the round one on top is the outlet air vent. And then the air is supposed to go down the inlet air vents and kind of like a fireplace, kind of be sucked up through the middle and come out the top. If that, and there's water can get in there, moisture can get in there, we get fog. I mean, and there's no drain in the bottom, so water gets in there. There's no drainage system. It's really a bad experimental design. It's only used one other place in the country, but this is a system that Holtec wants to put in New Mexico. This what I would consider an experimental system.
It's used only in one other place in the country, but
Currently, yeah.
But there are almost 100 nuclear power plants in the country. So how are they storing their waste?
The majority are in the upright cast that we looked at earlier, the upright thin wall canisters with the concrete and the air vent.
Above ground.
Above ground, yes. Everybody else is pretty much above ground.
The ones we're looking at?
Oh, no, the ones we're looking at is below ground. We actually have, at San Onofre, we actually have this, and then we have an above ground system also.
But you've got air vents coming in and going out, and I don't know how fine that mesh is, the inlets and the outlets. I have to believe that insects can get through there.
Yeah, well, all of the vent systems have to periodically be cleaned out. All kinds of little critters make nests and things in there, and that can shut off your cooling system. So that's one of the maintenance items, is to clean out the vents. So that the canisters don't overheat and the fuel doesn't overheat.
At least they do that much.
More or less, yeah.
More or less.
Yeah.
Now, the next image is interesting. We discussed that, and I find it quite interesting. So what's going on here?
Yeah, this is a closer up view of one of the canisters. You can already, yes, that's rust, where those thin air vents are. And they're huge air vents around. You know, every corner has an inlet air vent, and then the top is the outlet. So the canister's right under that lid. So, you know, it's exposed to coastal weather, you know, and this was installed not even a year, and you're already seeing rust on the vents there. So it's.
And pigeon poop, and everybody knows that bird poop is quite corrosive in itself.
Yeah, the seagull, yeah, they put these little sprays on there to try and keep the seagulls off. Yeah, they were pooping in there, and it was spilling into the vents and all of that. Those men that you see there are taking radiation levels from those vents. Those measured about 350 counts per minute right now coming out of those. This is a example of the only other alternative to thin wall canisters. It's a thick wall cast system. Thick wall casts don't use the thin canisters. They're thick wall metal casts. They're 10 to over 19 inches thick. Instead of a ½ inch thick, you've got 10 to 19 inches thick walls.
Of stainless steel.
Well, of either forged steel or a ductile cast iron that doesn't, these are containers that don't have cracking issues. And the external has a you know, a coated epoxy on it. You can get next to them, so they're maintainable. The better thick wall cast systems have double lids, double metal gasket seals. They have a pressure monitoring system. So if a seal needs to be replaced, they get an early warning to replace it. You can actually open it up and inspect what's going on inside. For example, in Japan, after the 9.0 earthquake and tsunami, they took their thick wall casts, they put them underwater in a pool, because you have to either have these underwater or in a dry transfer system and you have to handle them robotically. And they were actually found out that the baskets were starting to degrade. So they're able to make sure that the fuel is still in good shape to be stored and doesn't need to be, you know, handled to improve it. So it's a fully inspectable system. It's designed for longer term maintenance, both inside and out, and it's designed to be able to retrieve the fuel out if you need to put it in another container. The thin ones, you can't do any of that.
And all of this crenellation on top, all these the complexity you're seeing here, is places where they can be bolted.
Yes,
right?
These are bolted, independently bolted lids. So you've got redundancy. You've got double bolted lids, you only need one lid. You've got double metal seals in each lid, and you only need one seal for protection. It's got a lot of redundancy built into it.
And then you have something on the top called
That top lid is there for transport. You add that for additional protection if you're transporting in case there was a crash on the edges. So that's put on there for transport.
I'd like to go and compare the two systems, what we use in the United States, the thin-walled system, and then the thicker system used in most of the rest of the world. So would you go down the list and tell us what you know? Not all of what you know. I've discovered that you know too much.
I know too much. Yeah. Okay. So there is no repair technology for the thin canisters. They can't repair. They can't even find the cracks, let alone repair them. They can't inspect them inside or out. There's no monitoring system that will alert you to problems so that you can fix them before you have radiation leaks or helium leaks. The thick casts are the only ones that meet American standards of mechanical engineers. The ASME N3 are specific American standards for nuclear pressure vessels used for storing and transporting nuclear waste. And here we have American standards that only other countries are meeting. So if we required ASME N3 certified containers, we would only have thick casts in this country.
This is one of those, oh my God moments.
Yes, it's crazy.
And running down the rest of the list.
Yeah, the multiple defenses. So, you can monitor with the thick cast, you have monitoring, you have redundancy, you have the thick walls, you don't have the cracking vulnerabilities, fully inspectable, designed for longer term use. And also the Nuclear Waste Policy Act, which is a federal law. Before you can transport, you're supposed to have it stored in containers that can monitor and retrieve the fuel. So only the thick casts meet the current law requirements to be able to take this waste from where it sits now and give it to the Department of Energy. So it doesn't.
Wait a second. So we've got laws in place which makes the systems that we use illegal.
Well, the law requires the DOE, the Department of Energy, to only use monitored retrievable systems. The Nuclear Regulatory Commission is choosing to ignore that law. And when I brought this up to Mark Lombard, who was the director of spent fuel management at the Nuclear Regulatory Commission, he says, well, that law doesn't apply to us. It only applies to the DOE. And I said, well, but these containers are supposed to go to the DOE eventually. And his answer to me was, well, that's the DOE's problem. That's not our problem. That's the attitude of the director in charge of approving all these containers. That's what we're dealing with.
Another, oh my God.
I could not believe that. When I heard this, I had no idea. I assumed if you're handling, storing nuclear waste, you're going to have the best systems, and the regulator is going to be closely regulating, and the utilities are going to be extra careful because the consequences are so disastrous. I had no idea that the exact opposite was true in this country.
It could not be called the Nuclear Regulatory Commission. I'm trying to think of another better title.
The Nuclear Rubber Stamp Commission is what we have.
That's exactly what you read my mind. That's exactly what I would rename it.